So we're looking at scalar product. Scalar product is a way of multiplying two vectors and you'll get an answer in a scalar form, i.e. just a number, not a vector form. Scalar product is A dot B. It's also referred to as the dot product. For those of you going on to do advanced higher, you will learn the vector product. You don't have to worry about that higher. You're given it on the formula sheet, so you don't even have to remember it. What you're given on the formula sheet is A dot B is the magnitude of A times the magnitude of B times the cos of the angle between them. Theta is the angle between A and B. Or A dot B is A1 B1 plus A2 B2 plus A3 B3, where A is A1, A2, A3, and B is B1, B2, B3. So looking at these two in kind of simple terms. So here, calculate A dot B, where you're given the magnitude of A is 2, the magnitude of B is 3, and the angle between them is 30. So A dot B is the magnitude of A, magnitude of B, cos of the angle between them. So 2 times 3 times cos 30. 2 3s are 6. Cos 30 is root 3 over 2, so it's 3 root 2. Alternatively, you might be given the position vector of it, or the coordinates of it. So A dot B, your position vector of A would be 3, 0, negative 2. Position vector of B would be 2, 1, 4. So A dot B is A1, B1 plus A2, B2 plus A3, B3. So A1, B1 is 3 times 2. A2, B2 is 0 times 1. And A3, B3 is negative 2 times 4. So we get 6, 0, minus plus a negative is minus 8. So 6 minus 8 is negative 2. The nice thing is if you get a scalar product of a negative scalar product, what it will mean is the angle between the two vectors is obtuse. So it's quite a good way of checking. Similarly, if we want to find k dot k, so k is 0, 1, 0, 0, 1 from what we've done previously. So k dot k would be 0 times 0 plus 0 times 0 plus 1 times 1, which is 1. Or k dot k would be magnitude of k, which is 1, times the magnitude of k, which is 1, times the cos of the angle between them, which is 0, which will also give you 1 on that one. So looking at another one where we've been given the vectors in this form. So A dot B, write these as position vectors in column form. So 5, 1, 2 and 0, negative 1, 3. Be careful, remember, of that one. So A dot B is 5 times 0, 1 times negative 1, 2 times 3. So 5 times 0 is 0, minus 1 plus 6 is 5. What happens if you're given 3 points and asked to work out the angle between them? So it's asking you to find AB dot AC. So AB is B minus A, AC is C minus A. So we work out AB and AC, and then we do exactly the same thing, A1, B1, A2, B2, A3, B3, from these two vectors to get 20. One thing you've got to note is both vectors must be going away, i.e. both of them going away from the point or both of them coming into the point to allow us to get the scalar product correct. So let's look at the angle between vectors. So we know that A dot B is magnitude of A, magnitude of B, cos theta, which is A1, B1 plus A2, B2 plus A3, B3. When we rearrange, we leave the cos theta where it is and take the magnitude of A, magnitude of B over. We can get cos theta as A1, B1 plus A2, B2 plus A3, B3 over the magnitude of A times the magnitude of B. So looking at the first one, calculate the angle between these two vectors, PQ. So we do the magnitude of P, the magnitude of Q, and we do our A1, B1, A2, B2, A3, B3 on the top. So here, 1 times 1, negative 1 times 0, 2 times 1 on the top. We know how to do magnitude from previous. What we get is 3 over root 12. So we could simplify it, times it by root 12 and root 12. So we get 3 root 12 over 12. Simplifying root 12, we would get 2 root 3. So it cancel with a 4, ending as root 3 over 2. Inverse cos of root 3 over 2 is 30 degrees, which is pi by 6. A lot of the time, these will be given to you on the non-calculator paper. So in this one, find the size of the angle A CB, where we're given A, B and C. So we've got to have them both going away from our vertex of our angle, which is C. So we need CA and CB. We need them to be going away from here. So we work out CA, we work out CB, doing exactly what we've previously done. And then we pop it into the formula here. We work out A1, B1, A2, B2, A3, B3 with CA and CB. We also work out the magnitude of CA and the magnitude of CB. We pop them in. It will come out negative, so it's an obtuse angle. So our acute angle is 45. So the obtuse angle, second quadrant, 180 minus 45 is 135, or 3 pi by 4.